Dear students, today we are studying Wheatstone's Bridge. Wheatstone's Bridge consists of four resistors R1, R2, R3, R4. All these four resistors are connected between the points A, B, C, D as four arms of bridge. This is one arm R1 between A and B. This is another arm R2 between B and C. This is third arm between A and D, R3 resistance. Between D and C, R4 resistance. In that way, four resistors are connected. This is called Wheatstone's Bridge. And in one diagonal, say B to D diagonal, we are connecting galvanometer, which detects current. And in another diagonal, A to C, we are connecting battery, source of the EMF. This is called Wheatstone Bridge. Now, what for this Wheatstone Bridge is used? This Wheatstone Bridge is used to find out unknown resistance. For example, here four resistors are there, These four resistors can be related with one equation when circuit comes in balanced state. सर्किट बैलेंस स्टेट में आए समय ये चारों रेसिस्टर के बीच में एक इक्वेशन बनेगा. वो इक्वेशन यूज करके if three resistors are known to us, fourth resistor we can calculate. So in that way unknown resistance का value find करने के लिए this will be useful. Now first we have to get the equations by applying Kirchhoff loop rules. For example, first I am taking the loop ABDA. Is what? ABDA. ABDA loop I am taking. In this loop, I want to apply Kirchhoff loop rule. At first, I should imagine currents. That's why I imagine currents. See, this is the battery whose positive is this side, negative is this side. From the positive, current I is passing. And it will go up to point A, where it should be divided as two parts. So through R1, I1 current is passing. Through R2, the current passing is I2. That means what? I is divided as I1 and I2. Next, this I1 is going up to point B, where it is divided into IG and I1 minus IG. IG is passing through galvanometer and I1 minus IG is passing through C, B to C. That is through R2 resistance. And at C point, this IG which is coming through galvanometer and this I2 which is coming through R3, both will be added and will travel through R4, that is I2 plus IG. And from B to C what is coming? I1 minus IG. From D to C what is going? I2 plus IG. Both will be added and minus IG plus IG will get cancelled. Again I1 plus I2 which is equal to I will be going to the battery. In that way current is circulating. That's what we imagined. Now I am going to apply Kirchhoff loop rule for the loop A, B, D, A. Now in this way, A to B. First I am going from A to B. Means what? I am going in the current direction. When you are going in the current direction, the potential difference we should take as negative. Then how much is the potential difference? Wherever we find resistance, the potential difference is current into resistance. Through this path the current is I1 and resistance is R1. So current into resistance is what? I1 R1. But minus, because if you are going along the current direction, we should take minus. If you are going opposite to current direction, we should consider that potential difference as plus. Now A to B we have gone, minus R1, I1. Now B to D. B to D, when we are going B to D, in this path the current is IG and the galvanometer is present. It say it is having resistance capital G. So current is IG and resistance is capital G. So current into resistance is the potential difference. Means what? IG into capital G. But we are going from B to D means what? It is the direction of current. So since it is we are going in direction of current, that potential difference should be treated as minus. So minus IG into G plus. Next, now D to A. D to A, but here I2 current is coming from A to D, but we are going from D to A. Means what? Opposite to direction of current. Then potential difference should be treated as plus. So current how much? I2 in this branch and resistance R3. Means what? I2 into R3, but we should take plus. That's why I2 into R3. So total means what? We started from A and again we reached to A. Means what? One loop is closed. Closed path we have gone through. That is why the total potential difference must be equal to 0. This is the loop rule. So in this way, another loop I am going to take. Which one? BCDB. BCDB. In this loop, BCDB, see first B to C. B to C, what is the current I imagine? I1 minus IG. Resistance is R2. We are going from B to C means what? It is the direction of current. So we should take minus. So minus of R2 into I1 minus IG. Next, C to D. C to D we are moving, but current is coming from B to C. That's the opposite. Whenever current direction is opposite to our direction, then the product is plus. That's a plus. And current how much in this branch? I2 plus Ig. Resistance R4. So current into resistance is what? I2 plus Ig into R4. Next D to B. D to B also we are going opposite to current direction. So again plus Ig into G is equal to 0. Means what? We started from B, again we reach it to B. So means what? Total potential difference must be equal to 0. This is called Kirchhoff's loop rule. So in that way we got equation 1 and equation 2. Equation 1 we got if we apply Kirchhoff's loop rule for the loop ABCDA. Yeah, ABDA. And equation 2 we got on applying Kirchhoff's loop rule for the loop BCDB. Now what we have to do? We have to bring this Wheatstone Bridge circuit in balanced state. Balanced state means what? We have to make by somehow thus Ig should become 0. Means what? The current passing through galvanometer, which means what? The current passing through B to D should be made 0. How it is possible? It is possible among the 4 resistors by keeping R1 and R2 fixed, and R3, R4 we can change. R3 value and R4 value we can change as we can change R3 value and R4 value we can change. Means what? We can increase R3, we can decrease R4. Yeah, we can decrease R3 or we can increase R4. Like that, by changing, by keeping the suitable values of R3 and R4, we can bring the situation Ig becomes 0. Means what? The reading in the galvanometer will become 0, null position, that is called. So 0 reading, that is called balanced state. So if you bring that situation, means what? If we can make Ig value 0 by varying the values of R3 and R4, that is called we brought the circuit in balanced state. Then when Ig is B0 means what? Potential of B and potential of D must be equal, because whenever current always flows from high potential to low potential, here Ig direction is B to D. That is why we initially thought that B is at high potential and D is at low potential, and that is why current was moving from high potential to low potential. But by changing the values of R3 and R4, we brought B potential and D potential to same value. That is why when potential is same, current will not pass from neither from B to D nor from D to B. So we brought the circuit in balanced state, means this situation. What is that? Making Ig 0. Means what? Potential of B and potential of D should be equal to 0. That is possible by changing the values of R3 and R4. So that is why now when the circuit comes in balanced state, then Ig should be made 0 now. So wherever Ig is 0, we should write 0 in that equation 1 and equation 2. Then both the equations will become like this. Equation 1 minus I1R1 plus I3R2 is equal to 0. So wherever Ig is 0, we put 0. So that term got cancelled. Next, this becomes I1R1 is equal to I2R3. This is equation 3. Next, in the equation 2 also we should put wherever Ig is 0. Ig, we should put 0. Ig 0, Ig 0, Ig 0. Means what? Minus R2 I1 plus I2 R4. See, minus R2 I1 plus I2 R4 is equal to 0. Here is equal to 0 should be there. So is equal to 0. Is equal to 0. Then take this quantity, one quantity that side, it become R2 I1 is equal to R4 I2. This is equation 4. Now if you divide equation 3 to equation 4, I1 I2 I2 will get cancelled. You will get R1 by R2 is equal to R3 by R4. Means what? This is the relation among 4 resistors. So when the circuit comes in balanced state, we will get the one equation connecting all the 4 resistors. So from this equation, we can find out one value. Means what? Among this R1, R2, R3, R4, if 3 are known to us, 4th one we can calculate. So for that, it is useful. That is why this is the equation we derived. Dear students, today we are going to learn about meter bridge. This is called meter bridge or slide wire bridge. Meter bridge or slide wire bridge. This is based on Wheatstone Bridge only. Or this is also called Wheatstone Bridge. In this, what is there? 1 meter long wooden board will be there. 1 meter long wooden board. 1 meter long wooden board is there. Wooden board. On this wooden board, there are metal strips made of brass, iron, aluminum. This is metal strip in the form of L shape. L shape में metal strip. वो spread हो गया fixed. It is fixed to the wooden board. And this is also one more metal strip. And this is one more metal strip in the form of L. See, in that way, one metal strip, second, third. So there are three metal strips are spread on the wooden board and they are fixed permanently. And here one gap is there, this metal strip to this metal strip. In this gap, we have to keep one resistor, maybe resistance box. Means what? Known resistance. This is called known resistance. Known resistance. Let us call it R1. And here in this gap, between these two gap, we have to keep unknown resistance. Means what? One wire given to you, whose resistance we are going to find. That is a R2, unknown resistance. We have to keep in the second gap. And between A point to C point, what is present? One resistor wire made of manganese or nichrome. Manganese is made of manganese and chromium, which is alloy. Alloy will act as a resistance. That is why it is a resistor. A to C, one resistor wire, not connecting wire. It is uniformly made with uniform cross section area throughout the length. With uniform cross section area throughout the length is made A to C. So A to C, one resistor is there, uniformly made with uniform cross section area in the form of one string. It is there, spread between A and C. And this point is a B point, and this is A point. This is C point. Now between B and from B point we have to connect galvanometer. Galvanometer is what? Which will indicate whether current is passing through this or not. It will show deflection if current is passing. And the other end of the galvanometer we have to connect to jockey, which is present like this. Jockey. It is present like this. It is called jockey, which can be slided over the wire A to C. A to C wire है ना, ये wire पर वो jockey को जहाँ चाहे वहाँ contact में रख सकते हैं हम लोग. It's not movable. It is not permanent contact. The jockey can be kept anywhere in contact with the any point from A to C. A से लेके C तक ये wire पर कहीं भी contact में temporarily we can keep. The jockey can be brought like this. Jockey can be brought like this. Jockey can be kept in contact at any point on the wire A to C. It can be slided anywhere to get so jockey. And between A and C, battery is connected. Between A and C, battery is connected. Battery positive is towards A and battery negative is towards C. And these are circuit. And parallel to this AC manganese wire, which is we are calling resistor, 1 meter scale will be there here. Parallel to that, 1 meter scale will be fixed permanently to measure the length. Now length of this wire is 1 meter, 100 centimeter, A to C. Now what we will do here, this is actually based on Wheatstone Bridge. In the Wheatstone Bridge, how many resistors should be needed? 4 resistors. One is P, second Q, next R, fourth S. 4 resistors. Where are the 4 here? This is between A and B. This is R1. Between A and this is A and B. So between A and B, here we call him P resistor, but here we are calling A to B, I am calling resistor R1. And between B and C, the resistance is here Q. So between B and C, the resistance between B and C, resistance is R2, which is unknown resistance, whose value we have to find. And between B and D, between B and D, galvanometer. So this is B, galvanometer, and D, this is point D point. So D point we have to search over the wire AC. AC पर हम लोग D point को search करना. सर्च करने से बाद में मिलेगा. So D मिलने के बाद then for third resistor is A to D, one resistor is this wire. ये wire है ना, A से लेके D तक जिसका length L, it is one resistor. And D to C, another resistor whose length is 100 minus L. This is R4. So this is R3, this is R4. In that way, totally there are 4 resistors. 1, 2, 3, 4. And battery is connected and galvanometer is connected. So this is nothing but Wheatstone Bridge. Now, I told you this Wheatstone Bridge should be brought in balanced situation. Balanced situation means what? Galvanometer should read 0 reading. Galvanometer mein pointer should read 0 reading. For that, we have to change the values of R3 and R4. R3 का वैल्यू, R3 मीन्स व्हाट? A से लेके C D तक जो रेसिस्टेंस वायर है ना उसका रेसिस्टेंस. R4 मतलब क्या? D से लेके C तक जो वायर है ना उसका रेसिस्टेंस. दोनों का वैल्यूज चेंज करना हम लोग. इसको इंक्रीज या इसको डिक्रीज, या इसको डिक्रीज या इसको इंक्रीज करने के लिए रेसिस्टेंस डिपेंड्स ऑन लेंथ. दैट मीन्स लेंथ चेंज करने से रेसिस्टेंस चेंज हो जाएगा. फॉर एग्जाम्पल दिस जॉकी विच इज कनेक्टेड टू galvanometer, वो जॉकी कैन बी स्लाइडेड ओवर द वायर. If you are moving towards right, L value increase and 100 minus L value will decrease. Means what? R3 will increase, R4 will decrease. If jockey is brought towards left, then L value will decrease. That means R3 will decrease and R4 will increase. Means what? by sliding the jockey over the wire A to C, either towards right or towards left, we are increasing resistances R3 and R4. R3 we are increasing, R4 decreases. Yeah, R3 decreases, then R4 increases. In that way, we are able to change R3 and R value. We will search a suitable point D at where it should show zero reading. Galvanometer should indicate zero reading. At which point it happens, at that point we have to fix the jockey. After fixing that one, this is called R3, this length will become R4. Now you know resistance depends on length. Unit length resistance X only. Then R3 will be, this length is L na, so unit length resistance X रहा तो A से C D तक resistance कितना LX. So R3 is equal to LX. Similarly, unit length resistance X na, इसका length 100 minus L. So R4 must be equal to 100 minus L into X. In that way R4. Now, the galvanometer is showing zero reading. Means what, we have got the null position. That means what, circuit is in balanced state. So when circuit is balanced state, all the resistors are related with one equation already we got. Means what, R1 by R3 is equal to R2 by R4. Yeah, R1 by R2 is equal to R3 by R4. So R1 by R2. See, R1 by R2 is equal to R3 by R4. But R3 has equal to LX. So LX by R4 means what, 100 minus L into X. 100 minus L into X. X has got cancelled. L by 100 minus L. Then from this equation, R2 is equal to 100 minus L by L into R1. Means what? If R1 is known to us, then R2 we can calculate, provided L should be known. L means what? The length from A to D, at where galvanometer shows zero reading. So that point we have to determine where we have to keep the jockey from the A to C, at which point if the jockey is held, then it will show zero reading. Then this length L, and this length will be automatically 100 minus L. So in that way, R2 unknown resistance we can calculate by using this. So this is working on the principle of Wheatstone's bridge.